A strange new object has entered our solar system. It's travelling faster than any human-made spacecraft, emitting no tail, shining bluer than the sun. And according to Dr. Avi Loeb, a Harvard astrophysicist, it may have manoeuvred. They're calling it 3I Atlas, the third confirmed interstellar object in recorded history after Oumuamua and Borisov. But this one is unlike anything we've ever seen. Imagine watching live data from deep space telescopes, and suddenly the object shifts. Against gravitational expectation, no tail, no natural arc, just motion. That shouldn't be possible. On October 29, 2025, 3I Atlas passed closest to the Sun. In the days that followed, something incredible happened. The object increased in brightness by a factor of 5, and its light shifted to a blue spectrum. Something comets never do. This object isn't following any known cometary behaviour. And now, with its closest approach to Earth just weeks away, on December 19, 2025, scientists, government officials, and private research teams are racing to find out what 3I Atlas really is. Because it may not just be a comet, it may be a probe, a signal, or something else entirely. Stay tuned, because what happens next could change everything. If you're fascinated by deep space mysteries, hit that like button, drop a comment, and tell us where you're watching from, and what you think 3I Atlas might be. Imagine looking at a real-time 3D rendering of our solar system using Skylive or Stellarium. You zoom in near the inner planets, Mercury, Venus, Earth. Suddenly, a new object appears, barreling in from interstellar space, slicing through the ecliptic plane. On September 27, 2025, astronomers at the Atlas Survey System in Hawaii first picked it up, a faint dot moving faster than expected. Initially, it looked like a comet, but the trajectory was wrong. Its path wasn't bound by our sun. Instead, it had a hyperbolic escape trajectory, indicating it came from outside the solar system, just like Oumuamua in 2017. But 3I Atlas wasn't tumbling. It wasn't fading, and within days of detection, it started getting brighter, in a way that caught everyone's attention. The Virtual Telescope Project in Italy began live tracking it. NASA JPL's Horizon system confirmed its interstellar path, and by early October, experts from Harvard, ESA, and even private teams like the Galileo Project began gathering data. Let's take a moment to step back. Only 2 interstellar objects had ever been officially confirmed before. 1I Oumuamua, 2017, a flat, tumbling object with no tail and unexplained acceleration. 2I Borisov, 2019, a clear comet from beyond our solar system, with a tail and typical volatile behaviour. But 3I Atlas is different. It has jets but no tail. It's fuzzy in shape but rigid in motion. And most bizarre of all, its colour shifted bluer than the sun, a wavelength shorter than expected for its composition. That kind of spectral signature usually indicates an object hotter than 5e100 K, yet 3I Atlas, far cooler, somehow emitted blue-shifted light. On October 29, 2025, 3I Atlas made its closest approach to the Sun. It's perihelion, at a distance of 203 million kilometres. That's just beyond the orbit of Venus. Traditionally, comets heat up at perihelion and begin outgassing, releasing dust and gas, forming long tails. But what Atlas did was something no comet has done before. Between November 6th and 9th, multiple observatories, including the Las Vegas Galileo Project, Virtual Telescope Project, and the European Space Agency's Solar Monitoring Network, detected a rapid increase in brightness, a factor of 5 within just 48 hours. Simultaneously, spectrographic analysis showed a blueward shift, with 7 asymmetric jets emitting from the object's fuzzy core. But no debris trail, no coma cloud, no visible dust, according to Dr. Gianluca Marsi, who runs the Virtual Telescope in Italy. This isn't behaving like any comet we've seen. The light curve, the spectrum. It's strange. Very strange. And then came the bombshell. On November 7th, Dr. Avi Loeb appeared on Newsmax and delivered one of the most shocking public statements in modern astrophysics. It manoeuvred. He was referring to 3I Atlas's non-gravitational acceleration, an apparent deviation in its course that couldn't be explained by simple solar radiation pressure or cometary venting. Based on Newtonian mechanics, For an object to accelerate in space, it must expel mass, or be pushed externally. But no jets were visible in the expected direction, and the acceleration vector changed, just slightly, in a way that suggested intent. According to data from NASA's Jet Propulsion Laboratory, the deviation equated to an energy release consistent with expelling over 5 billion tons of material. Yet no such mass loss was recorded. Could 3I Atlas be using internal propulsion? Some skeptics insist the answer is still natural, perhaps a rare configuration of jets, or an unusually nickel-rich core causing unexpected interactions with solar radiation. Spectral readings from the European Southern Observatory and SO-host satellites confirmed something unusual. High nickel concentration, low iron ratios, no detectable carbon dioxide release. This composition is extremely rare in comets. Nickel is more common in metallic asteroids and planetary cores. Meanwhile, simulations from Caltech's Orbital Modeling Lab revealed a possible anomaly. The jets on Atlas don't align with its movement vector. Instead, the ejection appears to originate asymmetrically, possibly from beneath the visible surface. If that's true, it raises more questions than it answers. By mid-November, the mystery deepened. Congressional sources confirmed that Dr. Loeb had provided a private briefing on 3I Atlas to members of the House Committee on Science, Space and Technology. Representative Anna Paulina Luna publicly demanded NASA release all high-resolution images from the Mars Reconnaissance Orbiter's HiRISE camera, which may have captured frames during Atlas's solar approach. But so far, nothing has been released. NASA's official statement: "We are analysing the data and will release images once processed." That's unusual. HiRISE images are typically released within 72 hours of transmission. Now we're nearly 2 weeks past perihelion, and still waiting. Some have even suggested that NASA's delay is related to growing pressure from the Galileo Project and its open data model for UAP phenomena. Across forums, scientific communities, and alternative media outlets, speculation is reaching a fever pitch. Some theories include an alien probe using controlled propulsion, a derelict interstellar ship shedding mass, a self-replicating von Neumann fragment, a metallic natural object reacting to unknown forces. And while mainstream astrophysics urges caution, even some skeptics are now saying the evidence is at least anomalous. Interestingly, when compared to the infamous WOW signal detected in 1977, the angular origin of 3I Atlas lies within 9 degrees of the same region in the sky. Coincidence? Maybe, but maybe not. Let's return to one of the most baffling observations: the colour. Comets typically appear white or yellowish green, depending on gas emissions like cyanogen and diatomic carbon. But 3I Atlas, its light curve shifted blue, bluer than the sun in fact. Blue wavelengths are shorter and typically associated with hotter temperatures. But thermal models show Atlas remained well below 2000 K, meaning something else is causing that spectrum. Dr. Janie Chen from the Max Planck Institute for Solar System Research offered a hypothesis. If the surface is crystalline nickel or cobalt, and if it's rotating fast enough, it may polarize light in a way that mimics a blue shift. But that wouldn't explain the 5-fold brightening. In other words, even the best explanations are partial at best. According to current projections by NASA JPL Horizons, 3I Atlas will make its closest approach to Earth on December 19, 2025, at a distance of roughly 0.29 AU, about 43 million kilometres. That's close enough for ground-based radar imaging, as well as optical capture by Hubble, James Webb, and possibly the Vera Rubin Observatory. Scientists and independent researchers are preparing to record new jets or emissions, possible fragmentation. Any changes in speed or direction. Potential ejected sub-objects. Loeb believes it might be possible to intercept 3I Atlas, and has proposed a Juno flyby maneuver to intersect its path in March 2026. If approved, this would be the first human attempt to chase down an interstellar object in real time. We're standing at the edge of a cosmic unknown. A metallic object from beyond our solar system is about to pass closer than any other interstellar visitor in history. It's behaving in ways we can't yet explain. It shines in colours that don't match its temperature. It's accelerating without a tail. It may have even maneuvered. And as of today, some of the most powerful space agencies on Earth still haven't released their clearest images. As December 19th approaches, all eyes, human and robotic, will be trained on this mysterious object. Because one way or another, it's going to reveal something about itself, about the universe, and possibly about us. To understand how strange 3i Atlas really is, we need to compare it to its predecessors. In 2017, the object named 1i Oumuamua passed through our solar system. It had no tail, showed non-gravitational acceleration, and exhibited a highly reflective surface. It tumbled erratically, and its shape was estimated to be long and flat, like a pancake or cigar. But what made Oumuamua so puzzling was how it sped up as it left the sun, with no visible outgassing. That's what originally pushed Dr. Avi Loeb to publish his controversial theory that Oumuamua might have been a probe, a light sail from another civilization. Now, with 3i Atlas, the comparisons are unavoidable, but this new object is even stranger. Unlike Oumuamua, 3i Atlas emits jets yet shows no visible dust or gas trail. It is moving even faster, estimated at over 150 km/h, 3 times the speed of the fastest human-made object, the Parker Solar Probe. And most critically, its acceleration appears directed, possibly even controlled. Where Oumuamua tumbled and dimmed, Atlas stays consistent in shape, a fuzzy spherical mass with 7 visible points of emission. Are we looking at a pattern here? First one object, now another. Could these be scout vehicles or interstellar debris of something ancient? Let's load up Skylive or Stellarium again. If you project the trajectory of 3i Atlas, here's what you'll see. The object entered the solar system from a high inclination angle, close to the ecliptic plane. Not vertically like a random comet. Its trajectory was nearly coplanar with the planets. As of now, it's cruising between Earth and Mars orbit, heading back toward the outer system. Now here's the strange part. Using NASA JPL's Horizon system, orbital simulations show that even after its solar pass, 3i Atlas maintained a path that curves slightly inward, suggesting some course correction. Comet jets do not typically provide directional thrust. They're messy, uneven, and often cause spin or tumbling. But Atlas, its path adjusted in a way that's almost too precise, like it was aiming for December 19th, its closest Earth approach. The odds of a natural object choosing this exact trajectory are staggeringly low. Let's talk about the nickel anomaly. Spectral readings collected from ground-based telescopes in Chile, the Canary Islands, and the Subaru telescope in Hawaii all converge on one point. 3i Atlas is rich in nickel, with significantly lower iron content than any known comet. Why does that matter? Because traditional comets, especially interstellar ones, are expected to have a mix of volatile ices, like water, CO2, methane, and metallic elements in trace amounts. But nickel, as the dominant spectral line, is abnormal. Nickel is highly reflective conductive and used in engineering-grade alloys. Dr. Rina Espinosa at the European Space Agency summarised the dilemma in a public webinar. If you wanted to build a radiation-resistant hull for deep space travel, you'd want nickel or titanium, not ice. It's almost as if 3i Atlas was constructed, or at least originated from a metallic planetary body, not an icy Kuiper belt analogue. Telescopic imagery from the Virtual Telescope Project shows Atlas as a fuzzy central mass, with 7 sharp jets protruding outward. These jets don't follow the typical radial pattern of outgassing. Instead, they seem strategically aligned, clustered mostly on one hemisphere, and rotating in sync with the object's motion. Where's the tail? There isn't one. Even SOHO and Stereo A, solar satellites that routinely observe comet tails as they flare near the sun, failed to detect any trail or coma. That's not just odd, that's unprecedented. Every comet on record, when approaching the sun, emits some kind of debris tail due to sublimation of volatile ices. That's Comet 101. But 3i Atlas, no dust cloud, no halo, no debris. As if the object is venting in a highly controlled fashion, or the jets are non-material, like plasma propulsion. According to Loeb's team at Harvard and the Galileo Project field station in Las Vegas, the real kicker came on November 5th, when 3i Atlas changed acceleration vectors. Using data triangulated from Italy, Hawaii, and New Mexico, they recorded a sudden shift in trajectory that cannot be explained by comet outgassing alone. Here are the stats. Shift in velocity vector, kamixida 2 Equivalent force required. Expulsion of 500 million kg of mass duration. Under 3 hours, no visible mass ejection detected. In simple terms, the object moved sideways without losing mass or showing a reaction trail. Dr. Loeb's comment. You can't have thrust without fuel, unless the fuel is invisible, or the thrust is deliberate. That statement, it manoeuvred, has triggered everything from excitement to backlash to official silence. As of this moment, NASA has not released any high-rise images from the Mars Reconnaissance Orbiter, which had line-of-sight imaging opportunity during Atlas's perihelion pass. Why is that important? Because high-rise captures imagery at 30 cm pixel resolution, good enough to resolve jets, structural features, or fragment trails. But as of November 24th, nothing has been published. This has led to growing questions from congressional leaders like lunar independent researchers from SETI and the Galileo Project online open data communities, demanding transparency. The usual image delay excuse doesn't apply here. High-rise data is normally automated, and yet we're entering the third week of silence. Are they sitting on something extraordinary? Let's revisit a famous mystery from 1977, the WOW signal. It was a 72-second narrowband radio burst detected by the Big Ear radio telescope in Ohio. It's still considered one of the best SETI candidates for intelligent origin. Now here's what's eerie. 3i Atlas entered the solar system from a direction within 9 degrees of the WOW signal's sky coordinates. In the constellation Sagittarius near the galactic plane. Could that be random? Sure, space is big, but directionality in interstellar visitors is not random. Most known interstellar bodies are expected to originate from high stellar density regions, like the galactic center. That's exactly where both Oumuamua and 3i Atlas originated from. Are we being pinged from that region? Or are these drifting relics of something ancient, launched millions of years ago? We don't have the answers. Yet. Mark your calendars. December 19th, 2025. That's the day 3i Atlas will pass within 43 million kilometers of Earth, closer than Mars and within range of Goldstone Radar, NASA, Green Bank Telescope, Hubble Space Telescope James Webb, if redirected, possibly the Vera Rubin Observatory, Chile. If the object fragments, ejects pods, or changes trajectory again, this will be our last and best chance to observe it in detail. The Galileo Project has requested emergency telescope time across multiple facilities. Private satellite networks are being retasked. Even SpaceX has reportedly considered pointing Starlink sensors at the object. This will be a global science event and possibly a historical turning point. As of now, scientists are considering 4 leading theories for what 3i Atlas really is: a natural interstellar comet explanation, rare outgassing pattern, high nickel content, issue, no tail, controlled jets, blue colour, a metallic asteroid explanation, dense core ejected from exoplanet collision, issue, acceleration, colour shift, jet pattern, an interstellar probe, explanation, controlled motion, intelligent design, issue, extraordinary claim, requires evidence, a fragmented structure, explanation, debris from ancient craft or self-replicator, issue, unverifiable unless fragments are detected. Each theory carries profound implications, especially the last two. As of today, we are 25 days away from the closest approach. Each hour brings new data. Each image adds a new mystery. Each delay in official disclosure raises more eyebrows. If this is just a comet, then why isn't it acting like one? If it's a probe, then who sent it? And why? And if it's something entirely new, a type of object we've never categorized before, then our textbooks are about to change forever. The countdown has begun. As the days tick down toward December 19th, International observatories are preparing for the flyby of 3i Atlas with the urgency of a planetary defense exercise. Let's look at who's watching and how. NASA's Goldstone Deep Space Complex in California has already scheduled radar tracking. Its 70-meter antenna will bounce radio waves off the object to map its size, spin, and surface texture. The European Space Agency, ESA, has allocated time on the Very Large Telescope, VLT, in Chile, capable of imaging in multiple bands, from infrared to ultraviolet. The James Webb Space Telescope, JWST, is reportedly retasking for passive thermal imaging to detect internal heat sources or unusual emissions. Meanwhile, private efforts like the Galileo Project have set up temporary stations across Nevada, Arizona, and southern Italy to capture high-speed visual data. And most fascinating of all, a special session has been scheduled at the Vera C. Rubin Observatory, which isn't even fully operational yet. Emergency tests will be run to track Atlas using the LSST Legacy Survey of Space and Time infrastructure. Why the scramble? Because this is the best close-range shot we've had at an interstellar object ever. And it might also be the most mysterious. Let's zoom in on something strange. Starting November 10th, a sequence of time-lapse images from the Virtual Telescope project revealed a structural feature around 3I Atlas that defied categorization. Each frame showed a central spherical blur expected for comets, 7 consistent bright jets from fixed positions, a light halo that did not expand or dissipate. Astrophotographer Luca Marino noted that the jets pulsed every 6.3 minutes, with synchronized dimming in the infrared spectrum, as if something was rotating inside and modulating output. At first, experts thought it might be spin-induced jetting. But the math didn't line up. If the object were venting gas every 6.3 minutes from fixed points, it should tumble irregularly, leave a trail of debris, create a temporary coma. But none of that is visible. The structure has remained stable for nearly 3 weeks. And that's unheard of for any known comet. Infrared data from the Spitzer Space Telescope archive, reprocessed post-mission, and JWST's mid-infrared instrument, MIRI, show an unexpected twist. Despite the object's rapid movement and proximity to the Sun, 3I Atlas is emitting less heat than expected, yet its visible brightness has increased dramatically. This inversion, more visible light but less infrared heat, has triggered questions about what kind of surface or structure could reflect so efficiently while staying cool. Speculative hypotheses include a metallic surface with a high albedo, a hollow shell structure that insulates against heat, artificial reflectors, such as solar panels or layered platin Loeb, commented during a Harvard Q&A. Nature doesn't tend to build hollow reflective objects with constant jet emissions and no tail. That silence you hear from other institutions. It may be caution, or uncertainty. Privately, sources inside NASA Jet Propulsion Laboratory, JPL, have confirmed a division of opinion among mission scientists. One camp believes the data points to an exotic cometary model, perhaps with a highly metallic crust or an iron-nickel fusion that prevents typical tail formation. But the other camp, including some within the high-rise imaging team, are reportedly uncomfortable with the numbers. One anonymous engineer leaked the following calculation. For the acceleration observed on November 5th, 3I Atlas would need to eject mass at a rate of 250 gigajoules for 2 hours. Yet no mass trail is visible in any spectrum. That's not just a problem. That's impossible physics. These internal debates are fueling a quiet fire, pushing NASA toward a delicate decision: release images and risk sparking wild speculation, or delay and face credibility backlash. Meanwhile, independent researchers aren't waiting. Led by Dr. Avi Loeb, the Galileo Project is running its own live tracking of 3I Atlas from its Las Vegas array. Equipped with high-resolution cameras, AI tracking, and custom spectrometers, the project is fully independent. What they've discovered so far, the object does not tumble. It maintains a steady axis. Emission jets are not random. They repeat in precise intervals. Brightness surges are timed, not temperature-dependent. This raises the question, could these be signals? Loeb has not made any definitive claim, but during a November 18th livestream he said, "We're keeping an open mind. If this turns out to be a rock, so be it. But if it turns out to be a message in motion, we need to be listening." That last phrase, message in motion, is now circulating widely. In fringe science forums and even some peer-reviewed corners, a theory has begun to emerge. 3i Atlas might be a passive probe, designed not to communicate, but to observe. This silent probe model suggests the object is robotic, possibly self-repairing or modular, meant to pass through star systems and record data. This theory stems from Atlas's efficient energy use, low heat, high reflectivity, persistent motion control, lack of overt signal emission. If it's a silent observer, then it might never react. It might simply pass by, collect information, and report back elsewhere. Someday. That possibility terrifies some, intrigues others, but it's no longer being dismissed outright. Using data from the European Southern Observatory, Caltech, and Arecibo's old models, now maintained by an open source group, orbital simulations of 3i Atlas show something startling. If its current path remains stable, it will pass closer to Earth than originally projected. New trajectory range, closest approach on December 19th. Distance 41.7 to 43.2 million kilometers. Error margin plus 500,000 km. That's close enough to detect small fragments, if any, separate. Measure polarization in surface reflection. Determine exact shape using radar modeling. One simulation by Dr. Victor Hernández at Universidad Nacional Autónoma de México, UNAM, showed this. If the object emits a jet burst during Earth flyby, its velocity vector could shift again, sending it into a new interstellar trajectory. That would confirm controlled propulsion. In simpler terms, if it changes course near Earth, on camera, the debate is over. As the clock ticks toward the flyby, astrophysicists and SETI researchers are sketching out 4 main scenarios for what might happen. Total silence. Atlas passes silently. No changes, no fragments, no emissions. Verdict. Probably natural, but still unusual. Sudden jet burst. A new directional burst occurs, shifting its trajectory mid-flyby. Verdict. High likelihood of controlled propulsion. Fragmentation event. The object splits into smaller pieces. Verdict. Could suggest internal structure, maybe even designed modules. Ejection of smaller objects. Mini-objects depart the main body, in sync or staggered. Verdict. Highly suggestive of probe deployment or shedding behaviour. Each of these outcomes would lead to radically different interpretations, from exotic comet to intelligent design. And right now, no one can say which we'll see. On November 21st, 2025, a press conference was scheduled at NASA HQ, featuring speakers from JPL's Solar Observation Team, High-Rise Imaging Unit, Near-Earth Objects Program. Then, suddenly, it was cancelled. No reason given. Some suspect that internal reviews of the Atlas data, including still unreleased images, caused conflicting narratives. One NASA insider wrote in a private email leak, "We can't go out there and say it's just a comet if half the team thinks it's something else." Official silence continues, but the Galileo Project, SETI Institute, and even ESA are moving forward with or without NASA's input. The science doesn't wait. Let's pause for a moment. As of right now, today, November 24th, we are exactly 25 days away from knowing what 3E Atlas really is. Will it break apart? Will it reveal structure? Will it maneuver again? Or will it pass in silence, forever keeping its secrets? There is no reset button. There are no do-overs. We only get one pass, one chance, and the entire world will be watching. From Mauna Kea in Hawaii to Paranal Observatory in Chile, and from NASA Ames to the European Southern Observatory, something extraordinary is happening. For the first time since the Voyager Golden Records, Earth's scientific infrastructure is synchronizing to study a single interstellar visitor. Time slots for December 1821 are being booked by radio telescopes, listening for emissions, optical arrays, capturing movement, colour, shape, spectrographs, analysing emissions for unknown elements, AI algorithms, tracking trajectory changes in real time. There's even discussion of redirecting Earth-based laser arrays, not to send messages, but to measure reflectivity and scan for possible reactive responses. While no one officially claims this object is technological, the preparation is as meticulous as if it were. It's like a planetary open house for something no one fully understands. Interestingly, amid the high-tech race to observe Atlas, a new idea has emerged from the SETI Institute. Perhaps the silence is the message. They argue that if Atlas is a probe, its goal might not be to communicate, but to watch. In that scenario, what we're seeing now, the jets, the path, the unusual composition, could be part of an observational protocol, like a spacefaring version of a flyby drone. Its blue colour, a form of energy shielding or scanning light. Its jets, steering mechanisms or passive stabilizers. Its silence, a choice. In this view, 3i Atlas isn't trying to be found. It's simply doing what it's designed to do, regardless of our awareness. And perhaps we were never supposed to notice it. But we did. As public interest grows, a philosophical divide has formed in the scientific community. They argue we must stick to conventional interpretations. Their motto: extraordinary claims require extraordinary evidence. To them, Atlas is probably just a rare comet with weird properties, and our fascination reveals more about us than about the object. They believe dismissing anomalies is unscientific. Their motto: let the data lead the way. For them, the trajectory shifts, colour, and structure raise valid questions. Even if it's not a probe, they argue it could be proof of new physics, and that's just as groundbreaking. And then there's Camp C, small, quiet, and rapidly growing. Camp C, the listeners. They don't speculate aloud. They just point their instruments, collect data, and say, if something is watching us, we should at least look back. Back in September, Loeb proposed a last-minute intercept plan involving NASA's Juno spacecraft, currently in orbit around Jupiter. Here's how it works. On December 26th, Juno would perform a gravity assist maneuver. By March 16th, 2026, it could theoretically intersect the path of 3i Atlas if it maintains velocity. The mission would require a fast-track approval and collaboration between NASA, ESA, and private partners. Dr. Loeb's reasoning: if this is a piece of technology, even if abandoned, then examining it could teach us more than 50 years of theoretical astrophysics. The Juno intercept remains theoretical, but the discussion is real, and time is running out. Let's not forget the wider context. 2017, Oumuamua, flat, tumbling, accelerated. 2019, Borisov, comet-like but unusually pristine. 2025, Atlas, directional, metallic, jetting and silent. 3 interstellar visitors in just 8 years. Before that, none ever detected. Some experts suggest it's because we now have the tools to see them. Others whisper, maybe they've always been there and now something has changed. Are these cosmic breadcrumbs, relics of ancient travellers, or coordinated probes from a distant intelligence? We don't know. But it doesn't feel random anymore. Social media platforms are ablaze with theories, countdown clocks and speculation. TikTok: what if Atlas activates during Christmas? Reddit: 3i Atlas isn't a comet, it's surveillance. X, Twitter: NASA won't tell us. Galileo already did. Meanwhile, mainstream outlets are cautiously reporting, calling it a mysterious visitor, and hinting at unusual properties, but avoiding definitive conclusions. And yet, behind closed doors, media groups are preparing documentaries, emergency briefings, and even live-streamed coverage of the December 19th flyby. Because something might happen, and everyone wants to be the first to explain it. As 3i Atlas closes in, these are the moments to watch. Last full-spectrum observations before closest approach. Live tracking begins across major telescopes. Closest approach. Potential for new emissions or trajectory changes. Radar arrays activated. Second wave imaging begins. AI filters scan for ejected material or object fragments. Global debrief begins. All data from the day compiled into an initial snapshot. Expect near real-time data drops, visualizations, and, perhaps, a defining moment in astronomy. So what will we see? Will Atlas remain whole? A pristine interstellar comet? Will it fragment, revealing internal structure or subcomponents? Will it curve, accelerate, or change colour again? Will we witness something we've never seen before? Or will it simply pass, majestic, silent, and unknowable? The truth is, even silence speaks volumes. Even a non-event can be a message. Even a lack of answers changes how we ask the next question. Let's not forget, 3i Atlas didn't come looking for us. It didn't signal its arrival. It didn't request attention. It just appeared, gliding through our solar system with precision, mystery, and defiance of expectation. It bent light. It broke models. It drew the eyes of the most powerful observatories on Earth. Somewhere out there among the stars, perhaps there are others like it. Perhaps this is normal, and we are only now waking up to it. Or perhaps this was the first knock on our cosmic door. Either way, the moment is here, and it's ours to witness. So, what do you think 3i Atlas really is? Is it a natural interstellar wanderer with strange properties? A probe silently cruising past Earth? Or something else entirely? A message not in sound, but in presence? Could it be the most compelling evidence of extraterrestrial design ever recorded? Or will this be the mystery that haunts astronomy textbooks for decades to come? I want to hear your theories. Drop a comment below. Do you think 3i Atlas will reveal something on December 19th? Will it fragment, maneuver, or do absolutely nothing? I read every comment, and this time I'm especially curious what you think. And don't forget, this isn't over. We'll be making live updates as December 19th unfolds and releasing a post-flyby analysis with all the radar data, infrared signatures, and official reactions. So make sure you subscribe to the channel, turn on notifications so you don't miss the next video, and share this with someone who loves space mysteries, because no matter what happens next, the answer still lies in the vastness of the stars.